So at this point, it would be wise to group the tectonic plates from the in-between areas. So to do that, go to the Boolean and check on this A only pieces. Right now it says A pieces, but if we isolate what that group is by throwing down a color sop and selecting A pieces, it looks like that is actually referring to these in-between areas along here. So instead of calling that A pieces, let's call that in-between plates underscore group. So there's in-between plates. Let's actually call that in-between primary. You can call that whatever you want, but I'm going to say that, and then the inverse of this is going to be the primary group. So if we do that and then create a group sop, we can create the inverse of that as well. So I'm just going to paste this name right here as primary group, and I'll say that the group name is $OS. Base group is everything except for not A pieces, but in between primary underscore group. So basically I'm just taking the inverse of that so that now we have the primary group, which is right there. And we also have the in-between primary right there. Also, let's not capitalize that. So lowercase p on that, just a better convention. Okay, so great. Now that we have that, when we go to this clean sop, let's uncheck the remove group so that we don't get rid of that. And that should be just fine. We have position and then our two groups. Okay, from here we can use a split sop, and that will split the primary from the inverse. So set down a null, set that up to this input, and another null to the other input. This is going to be our primary stream. The other one is going to be our in-between primary stream. Okay, and just to color code that and make it all kind of cool, we'll say blue and light blue. Okay, so we're now going to focus on these primary shapes and break them up. And before we get too far, I find that it's always nice to divide, in other words, triangulate everything that we can, just so that in the future when we go to Boolean this stuff, it behaves a little bit more predictably. I found in general that it's just good to do that before moving on to anything else. Okay, so we have that divide there, and we no longer have any n-gons. So that's kind of the main idea. Let's go ahead and talk about how we're going to break up the edges of each one of these plates. And before we get too far with that, the idea is that we want to start off with our tests by isolating one piece of geometry. So I'm going to click this up here, go to 3D connectivity, and let's start off by just isolating, let's say, this piece right here. Delete non-selected. And again, we want to now focus on crumbling these edges. So let me bring up something in Photoshop and I'll show you how this is all going to work. So here's what I'm thinking about in my head before I do all this. We have a chunk like this, right? Now, we have a few options. We could try using a Voronoi fracture. We can try going for a Boolean. We could try doing the trace texture map thing that we just did, or we can have some combination of the above. Now, honestly, this trace texture map is not going to be a good idea. That's because the trace texture map thing works really good for primary forms, but it's not good for secondary or tertiary details. So let's not do that. Now, option one, the Voronoi, is a very common method that some folks will use. However, this is going to come with some challenges. Let's say that I have the points, and these points are isolated to only the edges right here. Again, we want points dense along the edges so that we can break them off, right? Well, what's going to happen is this. Because there's no points in the middle, it's going to give you shapes that look like wedges, essentially. So we'll end up with these kind of wedged out shapes that all kind of, convene here at the center. And this is not the best illustration, but the problem is that we're not going to really localize this terribly well, unfortunately, just because of these wedge shapes going towards the middle. And that just has to do with how Voronoi fractures work. And there's probably ways around that, but honestly, it's not going to be the most straightforward way of dealing with this. And honestly, the shapes that you get from a Voronoi fracture are usually very apparent. It's obvious when somebody does a Voronoi fracture. I'm not the biggest fan of it, and I think we'll get much better looking results, much better detail from a Boolean fracture. And so that's actually what we're going to do. We'll use the Boolean along with a few other tricks, but for now, let's not say Voronoi, not do option 3, and option 4, I don't know, let's just get rid of that too. Option 2, Boolean, is what we want. Now, one way or another, we need to have points scattered along the edge. So how can we achieve that? One idea you might think is to have a point as the centroid of the whole piece, right? And then we can try to measure any points and their distance away from that center point. So let's say I have some points, along here. I could try to measure the distance from the centroid to each one of these points. And then I could say, all right, well, if you're this close to the centroid, then go ahead and blast away those points. The problem is, though, is that as we're looking from the centroid, we have a circular radius that we're dealing with. And so if we have points out here, and this is an elongated piece, it's not going to cancel out these points without canceling out these points along the way. So it's really not the best way of doing that either. So we don't want to take the centroid and try to measure the distance. That's not going to work. Instead, let me just tell you what the answer is to this situation. So imagine we turn this into a volume. Again, we want to scatter points, and scattering points in a volume is pretty sweet, right? Because it goes inside the geometry. Now, we don't want the middle section, so what if we try to Boolean out just that middle section? We could take the same piece, a duplicate of it, and we can try eroding along the edges. So we just kind of push in along the normal of the edges of the volume. Well, if we do that and use it to cut into the volume, we'll only be left with just the exterior voxels. And then once we have this fog volume, we can scatter points, and that will isolate points to just the outer edges of the piece. So the first thing we need to do is Boolean out the middle of each individual piece, and that's going to involve a for each named piece loop. Let's go ahead and jump in Houdini, and I'll show you what that looks like.